Hello guys, you're all welcome back to my YouTube channel just for math. Okay, this is the second video on quadratic sequence. So in case you're yet to see the first video on quadratic sequence where I talked about how to identify and solve a quadratic sequence, it is very important to see that video before you continue with this. But if you've seen that video, then it means you're ready to continue and follow along with me in this video. So here my focus is on solving a quadratic sequence, right? Now if you recall, for those of you that have seen the previous video, you will notice that, or you would recall that we formed or generated a quadratic sequence. So here I'm going to solve that sequence and also give you one to try out to test your skills on what you've learned. Alright, in this video I want to solve this question which says determine Tn, which is the nth term of the quadratic sequence: 2, 5, 10, 17, 26, dot dot dot. Now this is the sequence that was constructed in the previous video. Alright, let's go about with the solution. Now if you remember, we said that the nth term of any quadratic sequence is always given by Tn, which is equal to an squared plus bn plus c, right? And I also did mention that you need to recall three equations: 2a equal to the second difference, okay, and 3a plus b equal to the second term minus the first term, and a plus b plus c, which is equal to the first term. You need to recall all these for you to be able to solve for the nth term of any quadratic sequence. So let's do that right away. We have to solve for the first differences. This is 3, this is 5, that is 5 minus 2, 3, 10 minus 5, 5, 17 minus 10, that is 7, and 26 minus 17 is 9. So here we have the first differences. Then we have to solve for the second difference, okay, which is expected to be constant. 5 minus 3, 2, 7 minus 5, 2, 9 minus 7, 2. Okay, now we can go ahead and apply these equations. Start with the first equation: 2a equal to the second difference. We have 2a equal to the second difference, which is 2. 2a equal to 2 implies that the value of a is equal to 1 when you divide both sides by 2. Also, we move on to the second equation, which is 3a plus b equal to t2 minus t1. Here is the second equation, and we've solved for the value of a as 1. Let's substitute those values. It's 3 times 1 plus b equal to t2, which is 5, and t1 is 2. So 5 minus 2 is 3. There we go. 3 plus b equal to 3, and therefore b is equal to 3 minus 3, that will be 0. So it means the value of b is 0. And finally, we apply the third equation: b plus a plus b plus c equal to t1. The value of a is 1, plus the value of b, which is 0, plus the value of c. Okay, c is yet to be solved, and the t1 is 2, which is the first term. Don't forget, this is the third equation we are applying. Then we have c equal to 2 minus 1, all right, and that will be equal to 1. So it means the value of c is 1, the value of a is 1, and the value of b is 0. Therefore, the nth term of the quadratic sequence, which is given by this equation: a n squared, the value of a is 1, so that will be n squared plus bn, the value of b is 0, 0 times n is 0, plus c, which is 1. So it means the nth term of the given sequence is n squared plus 1. N squared plus 1 is the nth term of this given sequence: 2, 5, 10, 17, 26, and so on and so forth. Alright, we can actually confirm if this answer is correct or wrong. So let's solve for the first term. We expected to have the first term t1 to be 2. Let's solve for that. T1 means whenever you see n, you substitute 1. That is 1 squared plus 1. 1 squared is 1. 1 plus 1, that is 2. So this is correct. Okay. And T2 is expected to be 5, right? Let's solve for T2. So this is going to be 2 raised to the power 2 plus 1. 2 raised to the power 2 is 4. 4 plus 1 is 5. This is also correct. Let's solve for T3. T3, it means we substitute n for 3. 3 raised to the power 2 plus 1. So 3 raised to the power 2 is 9. 9 plus 1, that is 10. This is also correct. Let's confirm T4. T4 is substitute n for 4. So that is going to be equal to 4 raised to the power 2 plus 1. 4 squared is 16. 16 plus 1 is 17, which is also correct. Let's try out T5. T5 means substitute n for 5. So 5 raised to the power 2 plus 1. 5 raised to the power 2 is 25. 25 plus 1 is 26. This is also correct. And it goes on and on like that until you solve up to Tn. So it means to solve for the nth term of this quadratic sequence, all you need to do is raise to the we have n raised to the power 2 plus 1. Okay, I hope you understand and enjoyed this particular video, and you've gotten the concept of quadratic sequence and how to solve for the nth term of a quadratic sequence. Okay, to test your skills or to test the skills you've just learned, I'd like you to put this into practice. So try this out. Determine the nth term of the quadratic sequence 72, 100, 120, 132, dot dot dot. So all you need to do is to solve this question and post your answers in the comment section. I would like to see your answers in the comment section. Okay, if you have any further questions, if you're unable to solve this question, please also drop a comment and I will make sure I solve the question for you guys. Okay, I hope you enjoyed this lesson. Thank you for watching, and I'm looking forward to seeing you watch the next video I will upload in this channel. So all you need to do for me right now is to like, share, subscribe, and click on the notification button to get notified whenever we post new content. Okay, thank you guys. I love you all. Goodbye.